Welcome back to this machine learning playlist. This is day 30 where we are going to learn about decision tree basics, having to make predictions and probabilities. So this is a new topic where we have previously covered about SVMs in a few set of videos. Now we are going to be looking at decision tree, and we are going to be having some learnings around here in the next set of videos as well. So, as always, few words that we are going to be looking at is Gini, samples, predictions, and max step. So, these are few things. So, decision tree is a um, decision tree is like a tree data structure where there would be a root node, and at each point there would be either a decision made whether it's true or false. If it's true, then we move to the uh, either left or right side portion of it, right? So uh, just to yeah, something like this, where at each node we have a decision either true or false, and there are levels to it, and this goes on and on based on the max step specified. Okay, so we are going to be importing the iris dataset again and loading it with all these four different values, and we are going to be removing these two columns. Those are the results. So we are going to train the machine learning model with decision tree classifier, which is going to be imported from tree class, and few other things here. So we can visualize decision tree as such with this piece here, and we are going to be printing out these values, features, samples, values, and class, right? So if it's of a Sentosa class, petal length is clearly less than 2.45. That's the clear feature distinguisher. And in case of versicolor, we have all the families which are having more than 7.5 and before 2.45 as versicolor, and we are putting all the other ones into the bucket of virginica. You see, there are also some amount of impurities that get distributed between versicolor and virginica because they are very close to each other in terms of their features. Okay, so yeah, there is something called as Gini parameter. In simple words, it's like a classification for one value to another set of set of classes in the same. For example, in this one, we have three separation of data with 50, 50, 50 to each class, and we could say that it's one third of a split for each class. So which means there is about 66% impurity for this class to the other two, so that's what it means. Or the 66% is of the other two classes when we are considering this class, so that's an example. Similarly here, if there are 10 classes and the other two are 0, it's 100% of this one or 1, and impurity of 0 in for the other two. That's about Gini parameter, and that's a simple understanding which should be understood very easily. So next is, we have this model. We can use a sample dataset to predict whether it's of a specific family and get some predictions and probabilities. Also, probability is like a numerical value or a percentage value. Prediction is like a classification technique. Okay, so we have other set of examples also which we are having to see results here. That's about it. And also we can have an leaf probability manually, so that's another thing. Yeah, so again we can have this small data set and have a train test split and do all sorts of things. Now coming to max depth as a parameter. Max depth is nothing but the levels in this tree. The more the tree depth that we specify or we want to would bring out the best result, or it would classify the data points much better. Or it's more the depth, more the accuracy, while there might be a chances of overfitting as well, while lesser the depth like 1 or 0 would create underfitting, right? So that's a simple analogy, since we always come across underfitting and overfitting analogy every now and then with all the machine learning models. So here, as you see, with max step 3, we get a close to good fit kind of thing where training and test accuracy is close. As we move, it's becoming like an overfitting thing, right? So that's a general analogy. If we remove the max depth parameter, machine learning model automatically adjusts and puts out some depth value and gives out a best accuracy. So that's one thing. This is also called as unrestricted tree, and this can grow considerably larger. In this case, it might be 5, but it can go even larger. 1, 2, 3, 4, 5. Right? You can go through this chart with this IPython notebook attached to this video. So those were few key things. There are few challenges and other set of learning items and summary of what we have started off with decision tree learning. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.